Standard C does not have a data type that is just a single bit. The smallest data type in a standard C is 8 bits or a single byte. However, it does provide us with bitwise operators that will allow us to manipulate the single bits within a single byte. So in here, I'm showing you a few of the low-level operators that we can see. So these operators are basically not AND or an XOR, and what we can do with them is actually we can be very creative, and I'm going to show you some with examples. So let's assume that we have some sort of a data D, and this is basically here in binary, and we're going to create a mask, and then what we're going to be doing is we're gonna use these particular operators to actually do something interesting with it with a mask. And generally speaking, this data and a mask is very commonly used in C to manipulate these bits. So the first thing is actually not, and not is the only unary operators that operates on a single operand. So in here I'm saying not 0, and it's basically is the maximum that you can get with an unsigned integer. Basically not 0, it will take the 2's complement, which is just basically a bunch of 1's in here. So the rest of them are really interesting. So let's see, D and mask. So what I'm effectively doing, I'm doing an AND bit by bit. So I'm doing an AND but these 2 bits by bits. And if you think about it, an AND with 0 is going to be 0. So effectively what I'm really doing is I'm telling it, hey, keep these 2 bits only and 0 out everything else. So the output in here, you can see with the AND, is that it kept these 0 and 1 and 0 everything out. And I isolated bit number 4 and number 5, and these are basically what the mask tells me. Similarly, I can do the opposite, where basically I can take the not of the mask and the not of the mask, which is actually it's the 1's complement, okay? So the 1's complement, not the 2's complement, because this is here, we're not dealing with negative and positive, we're actually dealing with a physical not gate, basically. So it's a 1's complement of that. So it's going to take that mask, and it's basically I'm telling it, hey, this will be 1, this will be 1, this will be 1, this will be 1, this will be 0, this will be 0, this will be 1, this will be 1. What I'm effectively telling it to do is keep everything but reset these 2. So what it will do is exactly that. It will make sure that these 2 are 0 and keeps everything else. The same goes with the OR operator. The OR operator tells me, hey, keep everything and make sure that these 2 are set. And the XOR operator just tells me keeps everything and keep these 2 here, or flip these 2, toggle them. This is basically just a toggle bit. So these are really neat. You can use the mask. It's very commonly used in embedded systems, that you basically create some sort of a mask and use one of these bit manipulation in C. However, dealing with a single bit, for example, setting it, resetting it, toggling it, is extremely common. So we're going to be providing you with some sort of a macro functions or macros, C macros, that you can basically set a single bit, clear a single bit, or toggle a single bit, or maybe read 1 bit, or maybe write into a single bit, or maybe create just a single bit. So these ones in here are actually inspired by Arduino. If you have dealt with the Arduino library, you're going to see that they have the same exact functions. So what I'm going to do is I'm going to just explain one of these. Let's take this one in here. So what this does, it does the following. So one UL stands for unsigned long. That means what I did is I created 1 0 0 0 0 0, and it's a bunch of zeros, probably 64 of them. And what I'm doing is I'm going to tell it, hey, let's assume that I want the data, whatever my data is, and I want basically to bit clear it. Basically, let's say that I want to clear bit number 5. What I'm doing is I'm going to say, first here, it's telling me, okay, let's shift that 1 by 5 location. So I'm going to say 1, 2, 3, 4, and this is 5, and a bunch of zeros in here. That's what the first thing happens. And then I'm going to take the not of that. That means it's 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, and a bunch of 1s actually all the way through. And now I'm going to take it with the AND of that data. So if you're taking it with the AND of this data, effectively you're keeping whatever the data in here will be staying the same, and in here will be staying the same, but whatever is under that 0 will be definitely 0. So the output in here will be the same, the output in here will be the same, and what I've effectively done is I cleared that particular bit with that particular location. The other ones can be explained in a similar way. Try them, and they're really not that difficult. Okay, so this is in terms of single bit manipulation. So whether you're dealing with a mask or a single bit, depending on the situation, of course you can utilize this clear, or like you can clear several bits with like different. For example, you can provide it 0, 1, 2, 3, 4, 5, or you can create it with a mask. It's up to you. There isn't a single way to manipulate bits in C. Okay, next what we are going to talk about is unpacking, and as if you probably remember, so all the I/O modules have 32-bit registers and they're arranged basically at 32. So you have 32 in here, 32 in here, 32 in here, 32 in here. Generally speaking, what we're going to be dealing with is we're going to be reading the 32-bit together, and what we need to do sometimes our data is not 32 bits. So to preserve memory and for other reasons that you're going to see later, we might just pack all of them in the same row. So let me give you an example in here. So this example in here shows me, let's say that I took this particular register, and as it turns out, it's containing the information for one character and another character and a 16-bit number. And what I did is I put them all in a single register that is 32-bit. So what happens in here, you're going to see in my code in here, is basically I'm going to read that particular register. I'm going to, of course, provide it with the base address and the register offset. So if I'm reading the first one, which is I'm basically just providing it with 0 and its base address in here. So I will be reading the 32-bit, but I know that these 32-bit are actually not necessarily a single data point. It's actually 3 of them. So this is 1 and a 2 and a 3. So what I need to do is I need to isolate it, and we're going to isolate it with shift and or one of these bitwise operators. So in here, I will isolate, for example, I'm interested in the number, which I know it's the upper 16 bits. So I'm going to actually create a mask that is basically a bunch of ones in the upper 16 bits. I'm going to AND it with the data. That means I'm zeroing out all of them on here. And then I'm going to shift it by 16-bit and that one here. And it's a very good habit to actually typecast it so that I'm guaranteed to, like after the shifting, the number will be here. And if I'm casting it, I'm canceling everything on the other side. And that now, the num will actually contains this, and I just unpacked it. Similarly, you're going to see that one here is the shift here. I know that it's actually the second byte, so I'm going to create a mask that has an FF in the second byte, and then I'm going to shift it by 8, and here it's just the least significant byte, and so forth. And of course, typecasting is important. So what I have done is the following. So I use one single register to store 3 different things, and this is why I actually can preserve the memory space that I have. Could I have just basically wrote a character 0 in one row and a character 1 in the second row and a number in a third row, for example, in different registers? Yes, you could have, but you would be basically wasting the rest of the 32-bit here, the rest of the 32-bit in here, and the rest of the 32-bit in here. So this way, by getting them packed into a single register, you're preserving a little bit of memory space. This was unpacking. You can of course have these 3 data type and pack them basically the opposite direction. So here we started by reading 32-bit, then we unpacked them into the different components. We can do the exact opposite. So for example, what we need is we need to figure out basically a character 0, character 1, and num, and we can actually do the same exact thing, but instead of the and, it's going to be an or, and I'm doing some sort of shifting. So you can follow what's happening in here. So first I created the num, and basically put the num in the first 16-bit, and then what I did, I basically shifted it by 8-bit. Okay, so I took this particular data point in here and shifted it by 8-bit, and then what I did is I brought the character 1 in here. Okay, and I basically concatenated it with it. So this is character 1. Okay, and this is num, and then next what I did is basically in here I shifted it by another 8-bit. Okay, so we're going to shift it by another 8-bit in here, and then the last one I basically concatenated character 0 in here, and then I'm going to take this packed information and I'm just going to send it through an IO write to the register I'm interested in. And that's how we can pack, unpack, and do some bit manipulations in C.